Okay, today I'm going to show you how to solve and graph inequalities. Now, if you have mastered the art of solving equations, these are pretty much the same thing. The only thing you have to keep in mind is this hint that I've put here. If you ever multiply or divide the sides of your inequality by a negative number, you have to flip the sign, right? So this would just switch directions. So that's the thing that you just gotta make sure that you remember, keep in mind. All right, but here we go. We're gonna solve for x, so we're just gonna add 5 to both sides. So it gives me 4x greater than or equal to 20, and we just divide by 4. Now it's just positive 4, so I don't have to worry about flipping the sign. I get x is greater than or equal to 5. So to graph my answer, I go to 5. Now you have to decide if you're going to use an open dot or a closed dot. This is greater than or equal to, so I'm going to use a closed dot. That represents that we're including 5 in our set of answers, okay? So x can be greater than or equal to 5. And this would be the graph of the solution. So if it's a greater than or equal to or less than or equal to, you're going to use a closed dot. If you just have greater than or less than, it's going to be open. Okay? All right, let's do number 2. Here we go. That's great, thanks. Okay, so now we have 4 minus 3p is greater than 16 minus p, so we have to get all of our p's together. So I'm going to add 3p to both sides. So I have 4 is greater than 16 plus 2p. Now we have to subtract 16. Now we're just subtracting a number. We're not multiplying or dividing by a negative number, so we don't have to flip the sign. So we get negative 12 is greater than 2p. And now we're dividing by 2. That cancels out. We have negative 6 is greater than p. All right. Now, if you solve your inequality and you have your variable on the right side, that's fine. Sometimes it's a little bit easier. I have kids that, if you have the variable on the left side of the inequality, then you can just follow the arrows to know which way to shade. All right. So x was greater than or equal to 5. The arrow was pointing to the right, so I just knew to shade to the right. But if your variable's on the right side, you can't just follow the arrow. So if you like that trick, you could just flip it around. You put p is less than negative 6. Now we know we're going to be shading this direction. So let's find our negative 6. It's an open dot because there's no line underneath. And we have to be less than 6. So we're shading in the direction of the smaller numbers, which is to the left. I had a student one time, he said, if there's a line underneath, make your circle complete. That's just a little rhyme you can use to remember when you fill in the dot. Okay, last example here, number 3. So this says, decide whether the inequality statement is true for all real numbers. And it says x plus y is greater than x minus y. Now, this one is obviously harder than the first two because there's no numbers, it's just letters, and we have to say whether that is true or untrue, regardless of what numbers we plugged in. Now, when I look at these problems, the first thing I'm thinking of is, can I simplify this at all? Because this is a lot to try and think about or even plug numbers in. So I say to myself, okay, well, there's x's on both sides of my inequality. So if I would subtract x from both sides, they're just going to cancel out. And then I have y is greater than negative y. Okay, that's a little bit easier of an inequality to manage. So if we want to check if something is true for all real numbers, I'm not going to sit here and plug in every single number ever, right? Because this video would be hours long. But one thing that makes it a little bit easier to decide if it's true is I just decide to plug in a negative number. You could pick any negative number. I plug in 0, and I'm going to plug in a positive number. Okay, so if I try a negative number, 0, and a positive number, and it works for all 3 of those, then this is most likely true. Okay, so let's plug in 0 for y. It seems like an easy one to check. Well, is 0 greater than negative 0? Well, negative 0 isn't even a thing, but that's not true, right? So automatically it doesn't work for 0, so it's not true. And that would be your answer, right? As long as you can just, wow. As long as you can find just one number that doesn't work for, you can just say it's not true. You don't even have to worry about checking the other numbers. There you go. Try the classwork examples and let me know how it goes. Thanks for watching.